Okay, thank you very much, Luciano, for this introduction. I have to say that in the previous talks, it's been already evident that there are a number of issues that need to be addressed for the in the field of the emergency, the management of emergency crisis. And I want here to remind the words also expressed by Paolo, from which it was rather evident that in many countries of the world there is one intrinsic difficulty is that it is necessary to create a large bridge between the scientists on one side and decision makers on the other side, okay? So in Italy, we have, in a sense, the advantage that because the civil protection exists since about 20 years, over this time, the Italian civil protection has created something that is intermediate between decision makers and scientists. So it is a well-structured way of integrating and making connection different parts. So in this talk, I will illustrate you how is organized the Italian civil protection system, in particular the scientific advice, decision-making, risk communication. So I wish, before I start my presentation, to thank once again Joe Gottsman for having accepted to collaborating with the Italian Civil Protection in the organization of this meeting, because I completely agree that there is a strong need of sharing experience at the international level. And it is very important in this sharing also identify very clearly where are the critical points that can make us to progress and to advance in improving our capability of dealing with the difficult problems of raised by volcanoes. So this is a summary of my talk. We'll spend a few words on the volcanic risk in Italy, and then I will focus on the problem of forecasting activity in the emergency cycle with some specific aspects related to volcanoes. Then outline the National Civil Protection Support Organization, scientific and operational. And then the scientific protection, scientific advice system, the decision-making process, and with some conclusive remarks. So here is a simple slide showing our active Italian volcanoes. I wish to remind here that we have had in the recent past various examples of crises here at Mount Etna. You know that Etna is the most important volcano in Europe, and also Stromboli. The last important crisis of Stromboli was in 2002 when the partial flank collapse of the Sciara del Fuoco produced a significant tsunami wave that affected the island of Stromboli and also the island of Panarea, essentially. Over the last half a century, in Italy, we didn't have any explosive eruption. The last one was that of Vesuvius that occurred during the last World War in 1944. For this reason, the Italian civil protection has gained some experience in dealing with the crisis related to basaltic volcanoes, with mafic volcanoes, Stromboli and Etna. But the Italian civil protection doesn't have so far a direct experience in dealing with explosive volcanic crisis that occurs in a densely inhabited area. And this is one of the focus of this workshop, to share experience with other countries on this matter. I also do remind you that in addition to subaerial volcanoes, active volcanoes, there are in Italy a number of submarine volcanoes. Only a few of them, and in particular Marsili here and the islands of the Sicily Channel, are considered as active. Mount Palinuro is very, very recently and might also be considered as a potentially active volcano. This is the well-known emergency cycle, the emergency cycle, but what I want to mention here is that in the specific case of volcanic emergency, the pre-disaster activity takes, in many cases, an importance that is much higher compared to other natural hazards. So the attitude of volcano to get closer to an eruption is quite different from compared to other natural risks like earthquakes or meteorological events. So in case of volcano, we have pre-eruptive volcanic arrests that somehow make possible that we can make evaluations about the probability of having an impending eruption. But the duration of these volcanic unrest can be quite variable. Typically in mafic volcanoes, we can have unrest phases that last only a few hours. So at Mount Etna, we can suddenly face a seismic crisis that within a few hours can evolve into a lateral eruption, producing a dangerous lava flow. So with very little capability of organizing ourselves for dealing in advance with the volcanic event. In contrast, there are other cases, typically cases of silicic volcanoes where that can produce explosive eruptions, where the duration of the pre-eruptive unrest can last for weeks or months, giving the possibility of developing preparedness plans and activities to protect people living close to the volcano. However, the fact that we have either strong or a long-lasting unrest do not necessarily mean that we will be successful in managing the crisis. Here, I have reported a couple of examples. This is a volcano in Indonesia, the Sinabung volcano, which showed very strong signals of unrest with strong earthquakes and increasing in gas emission up to the point to produce phreatic or largely gas-sustained explosions at the summit. And a result of these, there were 20,000 evacuees. So there was a kind of false alarm and an important evacuation of people, but with no real consequences. In contrast, we have cases of volcanoes that have been characterized by a long-lasting unrest. This can be, as an example, we can take the Nevado del Ruiz eruption in Colombia in 1985, where the signs of a weakening of volcanic activity started about 1 year earlier. But the eruption in the end that was produced was a relatively small eruption. The eruption caused a sudden melting of snow and ice that was capping the top of the volcano, releasing suddenly a large mass of water that eventually converted into a lahar that killed 23,000 people in the town of Armero at more than 50 kilometers from the volcano. So the lahar reached the town of Armero 3 hours after the onset of the eruption. So in this case, it is evident that there was somehow poor capability of responding to the event, although the signs of reactivation had started many months before the onset of the eruption. So there are extremes of this type. Now, in general, our way of making forecasting for an impending eruption is based on this simple concept that in a given moment we start to have signs of reactivation. These signs of reactivation tend to escalate, and in the moment in which these escalations occur, we make forecasting for an impending eruption. And this was successfully tested, for instance, in the case of Pinatubo. But at the same time, there are other cases in which the pattern that is followed is quite different. Here you see what happened in the caldera of Rabaul in Papua New Guinea, where these signs had a very fluctuating pattern until the eruption actually occurred. Or examples like the Long Valley caldera, where a long period of volcanic unrest and fluctuation of parameters, finally the system recovered equilibrium and anything happened. Or another example, the Akutan caldera in the Aleutianian, in which after a phase of sudden tendency to the reactivation, the volcano very quickly recovered its natural equilibrium without producing any eruption. So the duration of the unrest, especially when we deal with the silicic caldera-type volcanic system, is such that it becomes very difficult to make a robust prediction on what a given system can do in the future. So the problem of uncertainty that has been already mentioned and underscored by both Paolo and Joe, it is really such. Now, after this, that in somehow it was a reminder on the nature of the problem that we have in our hand, now I will enter in how the national zero protection system is organized. So a main point is that in the national zero protection system, there are two different components. One is the scientific component, and the other one is the operational component. On the scientific component, we see here that there are 3 different boxes. And these boxes, one is for the high-risk commission. One box is the so-called centri di competenza. Centri di competenza are scientific institutions that provide both monitoring data and also scientific evaluations to the department. The third box you see here, the so-called centro funzionale, is a structure within the departments that receive the information from the scientific centers and share the information both with the department itself, with the operational part of the department, and also among the different institutions, and also interact eventually with the high-risk commission. So the centro funzionale is a collector of information coming from the different scientific institutions that keeps an up-to-date on the state of different volcanoes, these different Italian volcanoes. In addition to these, we have external structures that also contribute with expertise or any kind of data or expertise to the centri di competenza and also to the operational structures. And there are also external committees that somehow interact on both the scientific and operational part. This is the total number of scientific institutions, Italian scientific institutions that collaborate with the Italian department. So there is a well-structured way of collaborating and interacting. If I restrict to those that are dealing with volcanic problems, by far the most important institution is the INGV. But in addition to these, we have also collaboration with CNR here for the INSAR information, with the Agenzia Spaziale Italiana for all the use of satellites for monitoring and evaluation during emergencies. Plus, we have the University of Florence here, and these are the 2 centers of Napoli and Bologna. I mentioned before the centro funzionale. The centro funzionale collect all the information coming from the scientific institutions. And in addition to these, we have also a selected number of signals of different monitoring activity on different volcanoes. So we have video cameras and a selected number of signals, not all of them, obviously, that are used somehow to facilitate the way in which we can follow the activity of different volcanoes. Which is the activity? The activity is to be an interface between monitor centers and the civil protection, and to represent an internal technical scientific structure. They take care of data and information acquisition, elaboration and sharing, risk evaluation according to procedures shared with operational component, and also to elaborate and releasing bulletins, informative bulletins on the activity of volcanoes. So it is a kind of daily and routine activity, and for the elaboration and evaluation of the signals, we can eventually use protocols, simple protocols for this sort of activity. Now, another important box that I showed before is the National Commission for High Risk Forecasting and Prevention. The high risk is structured in the way that you see below. There are different branches. I have highlighted here in red the volcanic component. So the three president emeritus, president, and vice president, and this is the volcanic sector. So dealing with this specific problem, the commission was appointed by the decree of the President of Council, and the duties are providing technical scientific advice on queries of the head of the department about different kinds of risks. So this is an important point highlighted in red, because the way in which the Commission interacts with the head of the department is, in general, on queries. So we put specific questions to the Commission, and the Commission give us its evaluation in relationship to these specific questions. The Commission also provides indication about how to improve the evaluation, forecasting, and prevention capability of different risks. Now, let's see. This is the composition of the present Commission. So, in the topmost part, you see Giuseppe Zamberletti, Luciano Maiani, and Gabriele Scarascia Mugliozza for the three role in the president's component. And then this is the list of experts that are making our volcanological commission. Professor Vincenzo Mora of University of Naples, petrologist. Alessandro Aiuppa, Professor Alessandro Aiuppa, fluid geochemist, University of Palermo. Professor Raffaello Cioni, volcanologist, University of Cagliari. Now he moved to University of Florence. Prof. Lucia Civetta, rock geochemist, University of Naples. Professor Massimo Coltorti, petrologist, University of Ferrara. Professor Francesco Dellino, volcanologist, University of Bari. Professor Rosanna De Rosa, volcanologist, University of Calabria. Dr. Marcello Martini, seismologist, INGV Vesuvius Observatory. Dr. Domenico Patanè, seismologist, University INGV Etna Observatory. Dr. Maurizio Ripepe, geophysicist, University of Florence, and Professor Giulio Zuccaro, vulnerability expert, University of Naples. So there are several universities represented. The experts are experts belonging to different disciplines. How it works, how the commission works, how it is summoned. It is summoned upon request of the head of the department, or it is also summoned on autonomous decision of the presidents, and it gathers at least once a year in joint sessions. The activity of the commission is to provide decrees on a scientific basis the hazard level for the diverse volcanoes, active volcanoes, alert level, furnishes regular advice to the department on volcanic hazard issues particularly relevant or sensitive, and respond to specific questions posed by the department. In addition to this commission, the department have also experienced more flexible and kind of advisory activity, the so-called the synthesis group formula. These were have been operating during the Stromboli crisis in 2003, 2007, and also during the Mesimex exercise at Vesuvius. The reason for the synthesis group is the rationale of this kind of panel of experts is that to follow on a daily basis what is going on at a given volcano during a crisis. So the National Commission gather only once in a while whether whether this kind of synthesis group operates on a daily basis during the crisis. The composition is, it includes experts of the volcano eruptive history and past behavior, responsibles of monitoring system, geophysics and geochemistry, and also civil protection officers. So usually in the past experience, the coordination was made by one member of the high risk commission. And the duty is on-site daily assessment of volcanic hazard during volcanic crisis, age 24 and 7 days. So how it works, the decision-making support chain. We have on the right side, there are the scientific institutions providing monitoring data and scientific evaluation in real time to the Centro Funzionale. The Centro Funzionale also receives information directly from the operational structures and territorial garrisons. This is a continuous evaluation that we make with, and the analysis results in a first-hand evaluation of the state of the volcano, if it is in an ordinary state or moderate activity or high activity. And the issues are ideally, these issues should be made on the basis of protocols that are used. And these are the kind of documents that can be generated, maps, provisional maps, bulletins, and the risk warning. At higher level, there are ordinary decision-making and extraordinary decision-making. The ordinary decision-making are taken by mayors, guides, and local authorities, whereas for extraordinary national level decision-making is the head of the department and in collaboration with prefectures that they make decisions or in case of national level problem, the structure is such that we operate either with the synthesis group for an intermediate level or for with the high risk commission in case of it is necessary to take higher level decisions. Another important aspect that has been already touched in the previous talk is that related to communication. Even in this field, the role of the civil protection is essential because during the communication we can limit ourselves to offer scientific explanations of phenomena or scientific evaluation, but in many, many cases when we deal with scientific communication, it is very difficult to separate a pure scientific content from a content that has some kind of implication in terms of civil protection. So for this reason, in the past experience that the department have done, has become clear that it is quite necessary to operate in tight coordination between different actors, scientists, civil protection, and local authorities. So the modalities of this communication can involve a press release, interview, contact center, website, and social network. The Italian system foresee that all these matters must be done in tight coordination. Scientists obviously can release and do release scientific information on the event. The civil protection releases information about risk evaluation in agreement with regional and local authorities and rules of behavior. All these parts are important because when the national civil protection takes a responsibility and a role in a local situation, we need to operate always in a very good connection with also local authorities, mayors, and so on. One more activity that for the moment the department has at level of at scientific level is our probabilistic models that also use expert elicitation. The event tree scheme connected with expert elicitation. For the moment, we do not have a routine use of this tool. Is something that we consider as possible in the near future. These kind of tools might help the risk communication to people, perhaps, and might also help the High Risk Commission to make their own evaluation. These are the conclusive remarks of my talk. Conclusive remarks state that compared to other natural risk, forecasting of volcanic eruption takes advantage from a significant precursory activity. However, in spite of these volcanic crises, especially those involving large human communities, like we have in Italy, in Campania, for instance, are made difficult by forecasting when, where, and how is probabilistic, eventually with large uncertainty. And two, uncertainty makes difficult both operational management and communication to people. Miscommunication of uncertainty can induce people to believe that volcanic eruptions are always predictable. Scientists know that it is not possible at present in the full form when, where, and how. Scientists need to get used to express their assessment in terms of probabilities and certainties, together with terms of reference with familiar events. And this concept has already been underscored even by in those that have talked before me. Long-lasting unrests doesn't mean easier forecasting capability. Instead, imply to greater need of preparedness, education, and communication. The last 3 points, a more effective way to get adequate scientific assessment for civil protection operational activity appears to have scientific advisory committees composed by experts with solid experience in volcanic processes, eruptive history, and volcano monitoring combined together. Properly calibrated probabilistic forecasting model can offer daily evaluation of the state of the volcano and help expert panels, but at the moment they can hardly perform better than expert teams. Finally, indeed, potential liability of scientists involved in advice activity combined with intrinsic uncertainty can at present result in a tendency to over-evaluate hazard, excessive size of area subject to evacuation, and also in a tendency to false alarm during crisis management. So this is my last point. I think that the present evolution, and in particular the consequence of what we had as a result of L'Aquila trial, might be quite heavy in, at least for the volcanic issues, because the combination of uncertainty and the possibility of liability of scientists might have very delicate and important consequences of the efficient and the right calibrated way in which scientists can assist the civil protection in making its decision. Thank you.